AI is solving one of biology's biggest problems, protein folding, and there's one big question with all of it: are we ready for it? It's fundamentally like the quote from Spider-Man: with great power comes great responsibility, and really we need to figure out what our responsibility is here. This technology could and probably will save many, many lives, but it may also cause massive harm if we're not careful. So today let's unpack some of the ethics and morals of AI and biology. First, I want to start with some history, because as we all know, looking to the past can often be one of the best ways that we can prepare for the future. Across time, there have been technological advancements that are paradigm shifts for society. Think about the printing press or the birth control pill. These things completely changed the landscape of how we even operate as human beings. Specifically looking back to the Industrial Revolution, I think we can glean some important facts and learn some important lessons. During the Industrial Revolution, there were many advancements in technology, specifically in factories, and people thought that this was going to kill jobs as machines were replacing many of the jobs that people had at the time. And as a matter of fact, this was the case. Many of the jobs that people had were indeed replaced. But here's the catch: many of the jobs that were replaced actually opened up new jobs for people to pursue. And this theme has held pretty much true historically. Think about when computers came out. These indeed replaced a lot of jobs, but think of how many programming jobs or computer jobs became available because of their advent. So from one historical perspective, it does look positive. With the new technology, some jobs will be replaced, but it'll open up plenty of jobs to overcome that fact. However, there are some historical facts that I think we do need to be wary of when it comes to new technologies. Particularly looking at medicine, we have some very positive but also some very negative things that have happened historically. Think about hand washing and germ theory, for instance. During the time that this came out, many people were very skeptical. After all, the idea that tiny microbes that we couldn't see, feel, taste, really detect at all with any of our bodily sensations were causing all of our ailments seemed pretty unlikely. But as we all know today, these tiny invisible microbes do give us the common cold, COVID, the flu, many of the illnesses that we suffer from still. And because of this theory, we've had much better health outcomes in these regards. More people are washing their hands, development of antibiotics, and so on and so forth. There's been a lot of good to come out of it. However, on the other end of the spectrum, we do have to look at some medical advancements that have had disastrous effects. And I think one of the most salient and notable examples of this was Merck and Vioxx. Merck is a pharmaceutical company, and in the early 2000s they created a drug called Vioxx. Vioxx was advertised as a painkiller and was thought to be a decent alternative to opiates for chronic pain. Eventually, after clinical testing and research done by Merck, Vioxx was approved to go to market as a painkiller. However, as more and more people started taking this drug, the FDA and the public started to notice something rather concerning. And that is thousands, tens of thousands of people were dying who were on Vioxx. So naturally, the FDA looked into this, and what they found was pretty disturbing. They found that people who took Vioxx had a significantly higher risk for cardiovascular events like a heart attack or strokes, and this was causing these people to die. And this wasn't just a few isolated events. This was to the tune of tens of thousands of people dying. So what happened was that Merck got sued, and at the time it was the biggest lawsuit in United States history. They got sued for over $4 billion for this scandal. But that's not even the worst part. The worst part is that Merck fudged the data to get Vioxx approved for market. Merck, as the pharmaceutical company who manufactured the drug, did a lot of the research for it, and that research was used to get it approved. And what they did was they manipulated just some very specific parts of this research so that the drug could be approved. Long story short, Merck falsified scientific information which ended up costing tens of thousands of people their lives. So looking back at history, we have a couple of points to note. First of all, new technologies may take jobs, but they also create new jobs. Second of all, new technologies can cause unprecedented economic growth. Think of life before the Industrial Revolution compared to now, or think of life before germ theory compared to now. It's a lot better in many ways. But we also need to be very weary of new technological advancements, as bad actors can really muddy the waters and end up costing people their lives. So with AI and protein folding, this really puts us in a bit of a pickle. But first, before I try to unravel that pickle, let's break down what protein folding is really quickly. If you want to learn more about it in depth, I did a whole podcast episode on this, but I'll give you the basics today. In a word, you have proteins in your body, and these proteins really perform all of the functions on a cellular level in your body. However, when your body is making these proteins, they start out as a long strain of amino acids, almost like a string, and to make that string useful, it has to fold into the proper conformation. Proteins are like tools, and they need to fold into the right shape, kind of like origami. And for decades, scientists have had to find out how proteins fold experimentally, and this process can be very expensive, very time-consuming, and very labor-intensive. However, in recent years, AI has really pushed the needle on this. Softwares like AlphaFold use AI to predict protein structure based off of nothing but the amino acid sequence. And more than that, they can actually help us create new and novel proteins. And the possible upsides of this are really astounding. And the things we can do with protein folding and AI are truly miraculous. Some of the prospects include understanding the human body at a whole new level, creating drugs that are very, very tailored and specific to you so that there's less side effects and that the drugs are more effective at what they do. Other things like having better methods to create antivenoms, or having proteins that eat plastics in the ocean, or even create lab-grown meat. Really, there's quite a lot we can do with this new technology. But naturally, this creates a lot of ethical dilemmas, especially now that we're bringing genetics into the conversation as well, because often with these proteins in our body, we have to figure them out with the genetic code. And if we were to make specialized drugs for you, we could feasibly do that if we knew your genetic code and then used it to create a drug specific to you. And you might start to see where some of these problems lead. First of all, I think the biggest one that springs to mind is designer babies and gene editing. Now, designer babies almost seem to be a bit of a counterpoint to the good side of protein folding and gene editing, and that is individualized medicine. Individualized medicine can take us in a new direction with medicine. Instead of having these broad, generalized techniques and recommendations, we can specify it to you. And this is huge because oftentimes with the research and the scientific data used to treat patients, you have to go off of the mean or the middle of that data. And the reason for this is because you can't do something for a patient that only works for 1% of people. It's best practice to do the thing that works for most people. And the issue with this is that a broad technique like this is going to work well for most people, but for some people it's not going to work well at all. For most people it's going to work reasonably well, and then for some people you're going to have hyper responders where it works really, really well. And the hope with personalized medicine is that we can eliminate that disparity. We can look at your genetic code and your individualized biology and give treatments that are specific to you that will work excellently just for you. However, problems start to rise up when you start asking, well, what if I want my child to be designed a specific way so that they don't have diseases? Well, this is perhaps the first step on the slippery slope where a lot of people might say, yeah, if we could find a pre-birth cure to genetically encoded diseases, I think that would be something that a lot of us could agree would be a very good thing if used properly. Now, the issue most people have with this, obviously, is that it's not too far of a step away to go from, okay, let's make it so that they're not genetically predisposed to, say, type 1 diabetes, to I want them to have blue eyes and be 6 feet tall. Because the fact of how genetic works means that those two operations probably don't look very different when you actually play them out and when you actually do them in an embryo. Furthermore, if we're doing individualized medicine with your genetic information, we really, really need to be careful about cybersecurity. Inevitably, we will be keeping your genetic information on a digital database, and the issue with that is that these digital databases are subject to data breaches. And it's one thing to get your algorithmic preferences found in a data breach, and it's something entirely different to get your entire genetic code found and used by bad actors and people with malintent. So increased cybersecurity in this space is going to be really of utmost concern, and it's not one of the sexier things that's talked about, but it is indeed very, very important. I think another issue here comes down to an idea of agency in medicine. If we're able to have extremely individualized medicine, then there seems to be little stopping us from fixing problems that may be agentic problems and not biological problems. Let me explain. It's pretty well known that antidepressants are overprescribed in the United States. Many people are on them that probably shouldn't be. And the rationale behind this is that naturally many people who are going to be on antidepressants are on them not because of a chemical imbalance in their brain, but because their life circumstances or whatever situation they find themselves in is sufficiently maladaptive to make them feel depressed, and that's a natural response. Now, that is not to say that antidepressants have no place or that they're not given to people with chemical imbalances in their brain, because in those cases, they're very useful and should be prescribed. The issue, of course, is that there's really no diagnostic way to 100% confirm which of the two we have. And I think the object lesson in this is that we need to be careful with medical technologies, because we don't want to use them and prescribe them and dole them out in a way that decreases your agency. Because in the instance of the group where your life circumstances are causing the negative mood and you have the agency and the power to actually change that, then giving the prescription drug may not be the best option. It may be a good stepping stone, but oftentimes that isn't the case, and that's not how they're given. Many people will stay on these drugs for years and years and years, which in turn means that the root problem can often be left unaddressed. And how this ties into AI is that if AI gives us even more personalized medicines that treat even more specific issues, at what point do we know whether or not we're treating issues that are of biology and issues that are of lack of agency? Now, these are a bunch of issues with AI and biology and medicine, but I think there's a couple of things that we can do as a society and as individuals to really address them. First of all, I think there is a huge importance of conversation in this space. I'll be the first to admit that many of these questions don't have answers yet, and that I don't particularly have answers to them either. Oftentimes they're a catch-22, as with antidepressants. We shouldn't stop giving them because for many, many people they do indeed help significantly. However, we still do have the issue of overprescription. And there's really no way to reconcile the two, as there is no biological test per se for something like depression. So in my opinion, one of the best ways we can remediate this is by having conversations and bringing everyone into the conversation. Because with AI, this is going to affect all of us. And in that vein of conversation, I think we need to have a few ground rules as well. First of all is going to be respect. If you're going to enter into a conversation like this with someone, which this is a hot button conversation for a reason, you need to have respect for the other party, respect for their opinions and their beliefs. And one of the excellent reasons for this is because they may know something that you don't, and if you don't respect them, you're not going to take what they're saying to heart. Which means you may miss out on very important information that can help you guide your decision making and your opinions and your beliefs. And similar to that, we need to all be very curious about this topic. In other words, we need to be open-minded and seek out where the actual information lies, where the chips land, so to speak. Because like I said, no one person knows everything in this area. No one person knows everything about AI and biology. No one person knows everything about AI alone or biology alone, for that matter. So it really does need to be a collective effort going in. And more than that, it's not just about who knows the most about AI or who knows the most about biology, because the problems we're facing are moral and ethical. And moral and ethical problems can't be solved with the scientific method or with computers. They're things that are shaped by each individual person's way they interact with the world and their experiences, as well as culture and history. And in this domain, nobody's voice should be left out. And this brings me to my third point on conversation that we need to keep in mind, and that's collaboration. See, one of the results of the fact that all of us have a voice and should have a voice in this conversation means that we all need to come together and talk about it. This conversation has implications that cross political lines, religious lines, and all kinds of belief systems. And having a diversity of ideas here is going to be vital. And one of the reasons for this is so that no one group, ideology, or person contains all of the power in this conversation. We need to try to make it as representative of everyone's shared beliefs as possible. And on that point, another thing that we need to try to be better about is trying to find the points of common ground. Our society seems more and more fractionated and divided nowadays, but in my opinion, I think that has a lot more to do with proliferation of extreme ideas on social media and people not going out and interacting with people and trying to find these shared beliefs. Because at the end of the day, we're going to share a lot of the core beliefs that are going to guide this discussion. Things like minimizing unnecessary suffering, promotion of healthy in-person communities where we're all interacting together in person, and more people living healthy and long lives, just to name a few. So when you have these conversations, try to be respectful of the other person, be curious about what they might know that you don't, and try to collaborate with them, seeing if you can synthesize and alchemize your ideas to create something greater than either of you had before you came into the conversation. And a couple more things I want to touch on here at the end is possible legislation that may need to be enacted in terms of AI and biology. Oftentimes, technology will advance out of control and way too quickly. We've seen this with probably social media and the internet, for instance. And a lot of times with technology, we need legislation to act as a buffer of sorts so that it can slow down and give us the time to catch up in the moral and ethical domains. What this legislation looks like, I really have no idea. But again, going back to the conversation side of things, talk with people, develop nuanced opinions, and then listen to lawmakers and see if their opinions sound valid or not. And also look at the laws that the lawmakers actually implement. I think this is something that is very lost on modern society, is actually looking what lawmakers do as opposed to what they say or what the media says about them. Start with the source, look at what they do, what they put into paper, and what they put into practice, and see what happens after they do that. And finally, some subsidiary conversations that I think we need to have in terms of AI and biology is, what does it mean to be healthy? What does it mean to be human? And what is best for humanity as a whole? Again, these are huge questions that I could do whole videos on, but I think for the time being, we can put a pin in that, and these are conversations to be had with other people. So let's summarize here. We've looked at history and we've seen how history has a lot of promise, but also some downsides that we need to be wary of. And because of this, we need to be very slow and intentional when designing AI and using it in medicine. We need to learn from the mistakes of the past as well as learn from the positives of the past and bring these together to give us the best shot at the future. So get out there, talk to some people about AI, talk to lawmakers, talk to AI scientists, talk to biologists, get all the information you can on the subject. And then develop an opinion and keep talking, share your opinion, bring nuance to it, learn about people's moralities, their ethics, learn about your own moralities and ethics. Because the important thing we need to figure out going forward isn't necessarily how to make the technologies, but how to use them. And fundamentally, that's a philosophical conversation that needs to be had with a lot of care and a lot of nuance. Anyways, thank you all for watching, and drop your thoughts below. What do you think the future of AI should look like?